So our last section in statistics, nothing too crazy new here, but histograms, this should be kind of familiar, and percentile ranks, which would be a little bit new. But if we take a look, just in general, a difference between a bar graph and a histogram. Like a histogram is really a bar graph, but the only difference is bar graphs usually deal with specific categories, and histograms have all data, and we're dealing with intervals. And I'll show you what I mean by these two graphs here. So if I look at the bar graph over here, the books read over the summer, I have categories, right? I have my different students, right? These are not numerical values, it's different students. And then it shows the number of books they read on the side. So for example, Hunter read about 5 books over the summer, okay? Just showing some data per category. Whereas a histogram, if you take a look, has intervals. So for our example, from 0 to 1 here, that is an interval. And if you look at these bins aren't even 1 wide. They're 0.5, right? This is from 0 to 0.5. So if I took a look at that bin right here, colored in green, from 0 to 0.5, it looks like there's about 41 for that frequency right there. So that bin's about 41. So that's all the numbers from 0 to 0.5 listed in that bin. So there's 41 total numbers. They could be like 0, they could be 0.1, they could be 0.23. They just have to be somewhere in that interval from 0 to 0.5. Okay, so that's the difference between bar graphs and histograms. And we're looking strictly at histograms here. And when you change the bin width, that can alter the way you look at your histogram. It can actually make your data misleading sometimes. So if I look at graph A and graph B, this is the exact same information. But if you notice, in graph A, what is our bin width here? Yeah, it's every 5, right? So our bin width are counting by 5s. Bin width is by 5s. Whereas in this one over here in graph B, what would be our bin width? Well, it still has dashes for every 5. But if you look at the bin, it's by every 2.5, right? It's like half of that 5. So our bin width over here is 2.5. And just by doing that, it changes the way our data looks. And just by looking at both these histograms, I don't know if you'd want to do either of these two, okay? Because the data is all kind of scattered. You got a lot of little pieces of data just here and there. So it's just not ideal. So basically what you usually want to decide what your bin width should be, you usually want to have a total of about 5 to 10 bins when you make a histogram. And in both cases here, they have about 5 to 10. Graph B has more, like what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one has 10, so that's pushing the limits. But you want to get a total of about 5 to 10 bins, and you want to be able to see some sort of action with your data when you create these guys. When you look at the actual dashes from the intervals, so if this says from 2 to 4, well, does that actually include the values of 2 and the values of 4 in there? Well, it just includes, if you take a look, the value that's in front. Okay, so 2s would lie in this bin, right? Same thing with anything between 2 and 4. So 2.6 would be in there, 3 would be in there, 3.4 would be in there. But 4 would not be, okay? So 4 does not exist in there. 4 would exist in this bin right here, this last one, right? So always look at the number that's in front. That's included, but the one at the end is not when you look at the bins, okay? So kind of tricky, but just be aware of that. The one in the middle is kind of nice because it has a description which it actually looks like. We call this mound shaped because it looks like a mound. It's going up and then it comes back down. That one's kind of nice. The other two are skewed slightly and it's kind of goofy, right? If I would say, is this left graph skewed right or skewed left? A lot of people think it's skewed right, but it's kind of backwards. It's skewed left. So you almost looked opposite. So it's basically skewed opposite of where most of the data. So the statisticians just decided to call that skewed left. Whereas this opposite one, now it's leveling out on the right side, so this guy would be skewed right. So it's almost kind of opposite what you would think there. So just kind of make note of that somewhere. And we could also have a bimodal histogram. And why do you think that is in this case? Well, it basically has like 2 mounds, right? Almost has like 2 modes, basically. Think 2 modes that occur the most, right? This bin and this bin. they both occur quite a bit. So bi means two. So really they have like two mounds in a way. That's where that bimodal comes from. So just some terms that go with our histograms. And the last thing we're going to look at is just calculating percentile rank. So the key thing is here, percentile, not percentage, right? That's different. Percentage is when you take like, yeah, he scored a 48 out of 50, which is a 96%. That's a percentage, right? So we're not dealing with that right now. We're dealing with a percentile. And what that does is it kind of compares your data or your score or whatever you're looking at with the rest of the data. So the number that you're going to get is the percentage of data values that is below the given. So the easiest way to do this is just look at an example. So if I wanted to find the percentile rank of 43, well, how much data is below 43? Well, I got 1, 2, 3, 4, 5, 6, 7 pieces are below. And the total, so 8, 9, 10 total. So 7 out of 10 gives me 0.7. And I multiply it by 100 or really move the decimal place 2 to the right to make it a percentage. Well, but we don't say percentage here. We say this is the 70th percentile. It's higher than 70% of the data. So that's what percentile means. So let's do one more just to take a look. So same thing, even if I'm looking for a percentile rank for a number that occurs multiple times, 43, right? Even if it's just once, like if I'm looking for one of the scores, I still look at just the data that's below it. So I got 1, 2, 3, 4, 5, 6, 7 pieces of data below over how many total? So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 7 divided by 18, which gives us 0.38888. So I'd move it 2 points. So it's about the 39th, we'll round it up, 39th percentile. So we usually round up to the nearest percentile, right? You never really see like, you're in the 38.8 percentile. They'd round up and say the 39th percentile there. Okay, so that's kind of the only thing that's new in this section.